Hello everyone, I'm Teacher Michelle and welcome to Unang Math. For today's episode, we will cover the topic about prime factorization. Okay, let's start. When you hear or see the words prime and factorization, it seems difficult to understand. But if you're going to take a look at it, the words prime and factor were our past lessons here in Unang Math. Prime refers to prime numbers. Factorization is a compound word. We have the word factor and the suffix ization. Let's recall briefly. When we say factor or factors, these are all numbers that divide another number evenly or with no remainder. The suffix ization here means it's the process of making something. So when we say prime factorization, you can think that this process uses only prime numbers. Okay, how are we going to write the prime factorization of a number? First, we need to list all the factors of that number. Okay, second, after listing all the factors, we need to identify all the prime factors among these factors. It means, among these numbers, what are the prime numbers? Those are the prime factors. And after identifying all the prime factors, we can now write the prime factorization of that number. So we just need to get all the prime factors and multiply together. Okay, let's give an example. Okay, let's find the factors of 10, prime factors of 10, and the prime factorization of 10. Okay, let's start with factors of 10. Okay, what are the factors of 10? We have 1 and 10. Always remember, 1 and the number itself are always factors of a number. Aside from 1 and 10, we also have 2 and 5. Okay, factors of 10, we have 1, 2, 5, and 10. Okay, now that we know all the factors, we can now identify the prime factors of 10. It means, among these numbers, what are the prime numbers? Okay, 2 is a prime number. It means 2 is a prime factor of 10. Okay, what else? 5 is a prime number. So it means 5 is a prime factor of 10. Aside from 2 and 5, no more other prime numbers. So we only have 2 and 5. Okay, now that we know all the prime factors of 10, we can now write the prime factorization of 10. Okay, we just need to get all the prime factors and multiply together. So 2 times 5, this is the prime factorization of 10. To check whether 2 times 5 is correct, okay, 2 times 5, the answer is 10. Okay, let's give another example. Okay, this time, let's find the factors, prime factors, and the prime factorization of 60. Okay, let's start with factors of 60. So what are the factors of 60? Okay, we have 1 and the number itself. 1 and 60. Okay, what else? 2 and 30. Okay, more. We have 3 and 20. Okay, what else? 4 and 15. We also have 5 and 12. 6 and 10. Okay, so these are all factors of 60. Okay, among these factors, what are the prime factors of 60? Or, among these numbers, what are the prime numbers? So those are the prime factors. Okay, 2 is a prime number. So 2 is a prime factor of 60. 3 is also a prime number. So 3 is also a prime factor of 60. Okay, what else? 4, it's not a prime factor or it's not a prime number. Okay, what else? 5. Okay, 5 is a prime number. So 5 is a prime factor of 60. 6, 10, 12, 15, 20, 30, 60. These are not prime numbers. So we only have 2, 3, and 5. Okay, now that we know all the prime factors of 60, we can now write the prime factorization of 60. So we just need to get all the prime factors and multiply together. So 2 times 3 times 5. But if we're going to check, 2 times 3 is 6 times 5. This is just equal to 30. Our original number is 60. So if you happen to get not the original number, what we're going to do is we just need to multiply this number by a prime number. And that prime number must be one of those prime factors of that number. Okay, so 30 times 3, it's not 60. 30 times 5, not 60. 30 times 2, yes, this is 60. It means we use 2 times. So how are we going to write the prime factorization of 60? So we have 2 times 2. Okay, since we use it 2 times, okay, times 3 times 5. Or 2, and we will raise it to the power of 2 since we use it 2 times, or 2 squared times 3 times 5. So this is the final prime factorization of 60. Okay, this process of finding the prime factorization of a number is long and difficult because we need to list all the factors and identify all the prime factors before we can find the prime factorization of the number. Okay, this time, I will show you two ways or two simple ways on how to find the prime factorization of a number. Okay, the first way is what we call factor tree method, and we also have division method. Okay, let's start with factor tree method. Okay, you are probably wondering why is it called a factor tree method? It's because of the word tree. Okay, it will look like a tree, okay, when each branch is split into factors. Okay, let's do it. Let's find the prime factorization of 90 using factor tree method. Okay, we just need to copy 90 or write 90 here. Okay, next is we need to write or draw two branches or two lines like this. Okay, and then we need to think of two numbers that when multiplied together, the answer is 90. So it can be 2 and 45 because 2 times 45, it's 90. Or 9 and 10 because 9 times 10, it's 90. Okay, in my case, I will use 2 and 45. So I will write it here, 2 and 45. 2 times 45, it's 90. Okay, next process. We have to say or we have to check if these two numbers are prime numbers. 2 is a prime number. Okay, so just leave it here. 45 is not a prime number. So we need to draw two branches or two lines like this and think of two numbers that when multiplied together, the answer is 45. So we have 5 and 9 because 5 times 9 is 45. Okay, check these numbers if these numbers are prime numbers. 5 is a prime number. 9 is not a prime number. So we need to think of two numbers again that when multiplied together, the answer is 9. So 3 and 3. 3 times 3, 9. Okay, this time 3 here is a prime number. So how are we going to write the prime factorization of 90? We just need to get all the prime numbers. So we have 2, okay, times 5, times 3, times 3. Okay, in writing the prime factorization of a number, okay, we need to arrange the number from smallest to largest. So 2 times 3, okay, times 3 times 5. Or, since there are 2, 3 here, so 2 times 3 squared, or raised to the power of 2 times 5. So this is the prime factorization of 90 using factor tree method. Okay, how about using division method? Okay, from the word division, it means we are going to divide. So 90 will be our dividend, and our divisor must be a prime number that evenly divide 90. So possible number here is, or possible divisor is 2. 2 is a prime number. So 90 divided by 2, the answer is 45. Okay, 45 is not a prime number. So if it's not a prime number, we need to divide again. So divisor must be a prime number. Okay, 5 can be, because 5 is a prime number. 45 divided by 5, 9. Okay, 9 is not a prime number, so continue dividing. Divisor must be a prime number, so 3 is possible. 9 divided by 3, the answer is 3. Okay, now 3 is a prime number. So how are we going to write the prime factorization of 90 using division method? So we are just going to get all these prime numbers and multiply together. So 2 times 5, okay, times 3 times 3. Okay, let's arrange this from smallest to largest. So 2 times 3 times 3 times 5. Or 2 times 3 squared, since there are 3 here. Okay, times 5. So this is the prime factorization of 90 using division method. If you're going to see, we got the same prime factorization. So it's up to you, what method are you going to use? This time, we will solve various problems involving prime factorization. But before we will do that, I will explain first this important property of square numbers, or perfect squares. When we say square numbers or perfect squares, these are numbers produced when a number is multiplied by itself. Okay, let's say for example, 5 times 5. This is equal to 5 squared, and this is equal to 25. 25 is an example of a square number or perfect square. Okay, another example, 7 times 7. This is equal to 7 squared, and this is equal to 49. 49 is another example of a square number or perfect square. So according to this property of square numbers or perfect squares, when a square number or perfect square is prime factorized, all the exponents of its prime factors are even numbers. Okay, exponents of its prime factors are even numbers. Even numbers, so we can divide by 2. Okay, example, we have here a prime factorization of a square number or perfect square. So 2 raised to the power of 4 times 3 squared times 5 squared. So all the exponents are even numbers. It means we can divide this by 2. Okay, let's divide by 2. 2 raised to the power of 4, when we are going to divide it by 2, so here is 2 squared, here is also 2 squared. 3 squared when divided by 2, so here is times 3, here is also times 3. Okay, how about 5 squared? When divided by 2, so here is 5 times 5, here is also times 5. 2 raised to the power of 2, or 2 squared times 3 times 5, this is equal to 60. Okay, this is also equal to 60. So 60 times 60, this is equal to 60 squared, and this is equal to 3,600. Okay, 3,600 is an example of a square number or perfect square. Okay, this time, let's solve the following problems. Okay, our first problem is 168 prime factorization is 2 raised to the power of a times 3 raised to the power of b times 7 raised to the power of c. So we will find the value of natural number a times b times c. So these are the exponents. So to find the value of a, b, and c, we need to find the prime factorization of 168. Okay, using the factor tree method, let's find the prime factorization of 168. Two numbers, when multiplied together, the answer is 168, 2 and 84. Okay, 84 is not a prime number. Okay, let's repeat the process. Two numbers, when multiplied together, the answer is 84, 2 and 42. Okay, let's continue. 42, two numbers when multiplied together, the answer is 42. We have 2 and 21. 21 is still not a prime number. So two numbers when multiplied together, the answer is 21. We have 3 and 7. Okay, this time 3 and 7 are already prime numbers. So what are the prime factors of 168? 2, okay, 2, 3, and 7. But 2 here is used 3 times. So the prime factorization of 168 is, okay, 2 times 2 times 2, okay, times 3 times 7. Or we can write it this way, 2 raised to the power of 3, okay, times 3 times 7. So this is the prime factorization of 168. Okay, now, we can now know the value of A, B, and C. So A is equal to 3. Okay, B is equal to 1. And C is equal to 1. To find the value of A times B times C, so 3 times 1 times 1, this is equal to 3. So our answer is 3. Okay, let's go to the next problem. Which of the following is not correct based on prime factorization? So we have here the numbers and the corresponding prime factorization. So we're going to identify which is not correct based on prime factorization. Okay, let's start with the first one. 20 is equal to 2 squared is 4, so 4 times 5 is 20. So A is correct. Okay, how about B? 30 is equal to 2 times 3 squared. 3 squared is 9, so 2 times 9 is 18 times 5, 90. 30 is equal to 90. This is not correct. Okay, how about C? 45 is equal to 3 squared. 3 squared is 9, so 9 times 5, it's 45. C is correct. Okay, how about D? 48 is equal to 2 raised to the power of 4. So this is 16. So 16 times 3, 18. 16 times 3, 48. So D is correct. Okay, how about E? 64 is equal to 2 raised to the power of 3 is 8. Okay, 8 times 8, 64. But, okay, in writing the prime factorization of a number, we need to use only prime numbers. 8 is not a prime number. So it means E is not correct. So the answer in this problem, or the answers in this problem, are B and E. Okay, let's check this next problem. What is the sum of all prime factors of 120? Is it 10, 11, 12, 13, or 14? Okay, to find the prime factors of 120, let's use division method. So divisor must be a prime number. So it can be 2. So 120 divided by 2, 60. Okay, continue dividing. Another divisor or divisor of 60 can be 2. So 60 divided by 2, 30. Okay, 30 is still not a prime number. So let's continue dividing. Divisor, okay, another 2. So 30 divided by 2, 15. 15 is still not a prime number. So divisor can be 3. 15 divided by 3, 5. Okay, this time, we can now know all the prime factors of 120. So we have 2, okay, 3, and 5. Okay, by the way, if we are going to write the prime factorization of 120, okay, since we have 3, 2 here, so we have 2 raised to the power of 3, okay, times 3 times 5. So this is the prime factorization of 120. But in this problem, we're just going to find the sum of all the prime factors of 120. Remember, prime factors are prime numbers. So, what are the prime numbers? 2, 3, and 5. So, 2 plus 3 plus 5. So, this is equal to 10. So, our answer is 10, letter A. Okay, and then now, let's see this last problem. What is the smallest natural number that can be multiplied by 375 to make it a square number? So in this problem, we are looking for the smallest natural number that can be multiplied by 375 to make it a square number. Okay, let's represent this problem. 375, when multiplied to this smallest natural number, okay, the answer is a square number or a perfect square. So in this problem, we are going to use, okay, the concept about the property of a square number or perfect square. So according to this property of square number or perfect square, when a perfect square is prime factorized, the exponents of the prime factors must be or are even number. So from that, we need to find first the prime factorization of 375. Okay, using division method, let's find the prime factorization of 375. Divisor can be 5, so this is 75. Okay, let's continue dividing. Divisor, okay, can be 5 again. 75 divided by 5, this is 15. 15 is still not a prime number, so let's continue dividing. Divisor can be 5. So 15 divided by 5, 3. This time 3 is a prime number. So the prime factorization of 375 is, okay, 3 times 5 raised to the power of 3, since we have 5 here. Since we have 3, 5 here. So 3 times 5 raised to the power of 3. So we write it here, 3 times 5 raised to the power of 3. Okay, let's go back to the property of square number or perfect square. Exponents of the prime factors must be must be even numbers. Okay, here, 1 and 3 are not even numbers. So what we're going to do is, we need to multiply this by numbers to make the exponents even. So we need to multiply 3 by 3 to make the exponents even. So this is 3 squared. Okay, and then 5 raised to 3, we need to multiply it by 5 to make it 5 raised to the power of 4. So we have 3 squared times 5 raised to the power of 4. So the exponents are already even numbers. So from this, we can divide this by 2. So let's divide by 2. So 3 squared divided by 2. So here is 3. Here is 3. So times 5 raised to the power of 4 if we are going to divide it by 2. So here is 5 squared. Here is 5 squared. Okay, 3 times 5 squared, this is equal to 75. This is also equal to 75. So 75 times 75 is equal to 75 squared, and this is equal to, okay, 5,625. So in this problem, the smallest natural number is 3 times 5 and this is 15. Okay, how about if I will add something here? 3 times 5 times 2 raised to the power of 2. Okay, in this case, it's okay because the exponent is even number. Even if I will add 4 raised to the power of 4 times 5 raised to the power of 6, as long as the exponents are even number. Okay, it's still correct. But since we are looking for the smallest natural number, so we have to remove all of this. 3 times 5 or 15 is the smallest number. Okay, 375 times 15, this is equal to 75 squared or 5,625. So our answer is 15, the smallest natural number.